Hello, dear students. So let's start today's lecture. Till now, we have learned about the properties of your uh, like uh, matrices and what are the additive properties existent of additive inverse. Okay, and also we have seen existent of additive identity element, associative law, commutative law, properties of matrix addition, where these all things. So in the previous lecture, we have talked about this. Now we will start our lecture after the continuation of that topic, and this is your class 12 maths chapter 3 matrices, and we have already covered two chapters of your class 12 maths NCERT that were what relations and functions, and second was inverse trigonometric function. This is your third chapter, so let's start the chapter and the properties of scalar multiplication of a matrix. So what is the property what are the properties of scalar multiplication of a matrix? If A is any matrix like Aij elements are there, and B is a matrix Bij are the elements in this, and these are two matrices of the same order. They have the same order. Say M cross N is the order of that, and K, L, L are scalars. K and L are here scalars. And then we have K into A plus B. Like if we have K multiplied to whole A plus B, okay, so we can write it like Ka plus Kb. So that is also obvious thing, because if you have like K multiplied to A plus B, then you can just open the bracket and just multiply this with both the matrices. Okay, this will give the same result. And the second property is what? K plus L into A is equal to Ka plus La. This is also obvious, because if you have two scalars K plus L and they are multiplied with capital A in the bracket, so the bracket will open, the both the scalars will be multiplied to A like individually. Okay, now we will see some like proof of this and how this has come. Let's start. So if you have like Ka plus B, that can be written like what? K into Aij plus Bij. And this is also equal to Kaij plus Bij that we have talked earlier, means in the yesterday class. So it is equal to K into Aij plus Bij in the bracket, which is equal to Kaij plus Kbij in another brackets inside the matrix. And if you like open it, you will get Kaij matrix plus Kbij. Okay, see here. You are getting what? Kaij plus Kbij, which is equal to Kaij plus Kbij. That is equal to Ka plus Kb. That is how it is written. Only for your second property, that is K plus L into A, your proof is here. So K plus L, write the A matrix as Aij element of this in the your matrix sign. When you multiply both the scalar products to Aij, then Kaij plus Laij will come. Then Kaij plus Laij will separately will be written equal to Ka plus La. Okay, so that is how the scalar multiplication of a matrix is done. So let's move further and see what is the next thing. So you have example 8 here. If capital A is the matrix 8, 4, 3, 0, minus 2, 6, and B is the matrix 2, 4, minus 5, and minus 2, 2, 1, then find the matrix capital X such that 2A plus 3X is equal to 5B. Okay, so you have two matrices A and B, and we have to find a matrix X such that 2A plus 3X is equal to 5B. So just write it like 2A plus 3x is equal to 5b. Then you can redistribute this whole equation, and you can write it like 3x is equal to 5b minus 2a. Okay, just move the 2a to the right hand side. You will get the expression like this. So x will be equal to what? 1 by 3 into 5b minus 2a. Just see here. Here you are getting like this. So x will be equal to what? 1 by 3 times of 5b minus 2a, or x is equal to 1 by 3 into 5 and multiply 5 by matrix b. So write the matrix b here, minus 2 times a. So you have to write a also here. Just now 1 by 3 times, multiply 5 inside this matrix and minus 2 inside this matrix, and just add them, finally you will get the result. Okay, and then in the next last step you can divide also by 3, because 3 divided outside the matrix, it will divide all the elements inside the matrix here. Yes, you can observe here that 1 by 3, and here the matrices are added, and like elements of matrix are added, and 1 by 3 times minus 6 minus 10 12 14 31 minus 7. So after that you will just divide each element by 3. It will come minus 2, it will come minus 8, 10 by 3, then 4, then 14 by 3, then minus 31 by 3, and minus 1 by 3. So that is how you got this matrix. Okay, let's move further and see the next part. Find x and y if x plus y is equal to 5209 and x minus y is equal to 3 6 and 0 minus 1. So here you have to find out like x and y, if x plus y is this and x minus y is this. So you can write it like what? X plus y x minus y can be written like x plus x, okay, plus y minus y. Because addition is also your commutative, so you can write it like that also. After writing it, you will get the result as 8808 and 2x is equal to 8808 only. Okay, because x plus x plus y minus y will give you 2x only. Y and y will be cancelled out. We will get x is equal to 1 by 2 times 8808, or equal to 4404. Okay, that is how you calculated this. Let's move further and see the next thing. So from here you got that x value, and also you can get the y value by x plus y minus x minus y term. Here x terms will cancel out and y terms will be added. We will get 2y is equal to 2 0 minus 4 and 10. After just like dividing y by 2, you will get 1 minus 2 0 5 as the y matrix. So this is how you got both the matrices x and y. Okay. Now we will move further and see what is the next thing. Find the values of x and y from the following equation. So here also we have addition of two matrix which is given to another, equal to another matrix. So just compare both the terms of left hand side and right hand side, and you can find out the values of x and y here. Okay. So it is easy. I will leave it for you and you can do it by yourself. It is easier example. Okay. So here one example is given. Two farmers Ram Kishan and Guru Charan Singh cultivate only three varieties of rice, mainly Basmati, Parmal, and Nora. The sale in rupees of these varieties of rice by both the farmers in the month of September and October are given by the following matrices A and B. So the A and B matrices will give you the varieties of rice by both the farmers, and their sales also. So here A matrix will give the your September sales, and B matrix will give you October sales. So for A matrix, you can see that Basmati is sold by 10,000 numbers, and it is like by Ramkishan. And for Guru Charan, it is 50,000 in like sales. and Parmal is like 20,000 and 30,000. Similarly, Nora is 30,000 and 10,000. This was your September sales, and similarly, your October sales are B is equal to 5,000, 10,000, 6,000, and 20,000, 10,000, and 10,000. Find the first part of this is written here. Find the combined sales in September, October for each farm and each variety. So you have to do what? You have to just add the required rows and column terms or elements. You will get the result. Find the decrease in sales from September to October. This is like your decrease in sales. If both farmers receive 2% profit or gross sales, compute the profit for each farmer and for each variety sold in October. Okay. So these are some parts you have to calculate. First part is calculated as combined sales in September and October for each farmer and each variety is given by. So A plus B will give you what? Combined sales in September and October month. We have to add each elements of corresponding each row and column of corresponding matrices, both of the matrices, and add the elements of that. So we will get basmati as 15,000. Okay. Here what he has done that he has added the basmati sales. So 10,000 and 5,000 will be added and it will give you 15,000. Similarly for second row and first column, you will get 50,000 plus 20,000 as 70,000 the resultant. Okay, here you can see 70,000. So similarly, you can add all the elements, corresponding elements of each row and column. Okay, and change in sales. Second part is change in sales from September to October is given by. So here you have to find out what A plus B you have already found out. Now here you have to find out A minus B. So A minus B will give you what? 5,000, 10,000, 24,000, 30,000, 20,000, and 0. Okay. So I hope that you got it, that how the elements of your required change in sales are calculated here. Now we will see the third part of this. 2% of B is what? 2 by 100 into B, that is equal to 0.02 of B. So we have to multiply here what? 0.02 to whole matrix. Okay. So 0.02 is multiplied to A minus B matrix, and you will get the result as 100, 200, 120, 400, 200, 200. So thus in October month, Ramkrishnan received rupees 100 for rupees 100, rupees 200, rupees 120 as profit in the sales of each variety of rice. So this is your profit here. Okay. Because 2% of in the question it is already given that both the farmers receive 2% profit on gross sales. Okay. So compute the profit for each farmer and for each variety sold in October. So we have to calculate the profit here by like uh, taking the difference and then multiplied by 0.02. So you will get this result. Okay. Multiplication of matrices. So now the another topic which is very important is multiplication of matrices. So how can we multiply two matrices? We have already seen that we can how we can add the matrices and how we can take the difference of matrices. Okay, and also we have seen that how to take the product scalar product of matrix. So these points we have already covered. Now we will see that how can we actually multiply two matrices. This is like uh, tougher side or a tricky one because you haven't seen multiplication of matrices. Suppose Mira and Nadeem are two friends. So here we have to suppose that there are two friends, Mira and Nadeem. Mira wants to buy 2 pens and 5 storybooks. So Mira wants to buy what? 2 pens and 5 storybooks. Okay. While Nadeem needs 8 pens and 10 storybooks. And then Nadeem wants to buy 8 pens and 10 storybooks. They both go to a shop to inquire about the rates, which I have quoted as follows. So pen available at rupees 5 each, and storybook is available for rupees 50 each. How much money does each need to spend? So we have to calculate that how much money each have to spend here. Clearly, Mira needs rupees 5 into 2 plus 5, 50 into 5. So you can see here that we have to multiply Mira, like how many pens she has to buy and multiply it by 2. 2 is multiplied by 5 because each pen costs 5 rupees. So we have to multiply 2 by 5. Similarly, for your storybooks, I have to multiply 5 by 50. Okay, that is rupees 260 will be the resultant. While Nadim needs 8 into 5 plus 50 into 10 rupees. So that is also similar to like Mira calculation. That is rupees 540. 540 is coming for Nadim. In terms of matrix representation, we can write the above information as follows. So requirements is the one matrix. We can write it like 2, 5, 8, 10, and prices per piece in rupees can be written in the matrix form as 5 and 50. Okay. Money needed in rupees. How to calculate money needed? So I have to multiply like 2 and 5 to 5 and what? 2, 5 of this multiplied by 5 and 50 of the corresponding second matrix. Okay. So it is like multiplying horizontal to vertical arrangement. So you can observe this pattern that here matrix multiplication is like horizontal elements are multiplied to vertical elements, or like that uh, system is followed here, and then we add the multiplication terms. So here 5 into 2 into 5 or 5 into 2. So 2 into 5 is added with what? 5 into 15. This is the first element of your production matrix, product of two matrix. Okay. Okay. And what is the second element of this matrix? 8 into 5 plus 10 into 50. So this is like multiplied by this one, vertical arrangement. This arrangement is multiplied to vertical arrangement. So you will get the 540 as a resultant. Suppose that they inquire about the rates from the another shop quoted as follows. So pen is rupees 4 each and storybook is rupees 40 each. Now the money required by Mira and Nadeem to make purchases will be respectively rupees 4 into 2 plus 40 into 5. Okay. So here the second case is for another shop, and here you can see that the rupees are coming different. For Mira it is 208 rupees and for Nadeem it is 432 rupees. So this is the second case here. So I will rub this part and move to the second thing. Okay. Again, the above information can be represented as follows. So again, we have done the same thing, and we just done the multiplication here also. So 2 and 5 will be multiplied to what? 4 and 40, and 8 and 10 will be multiplied to 4 and 40. And they will be added separately. Okay. So what you will get here? 208 and 432 as the resultant. So that is how you calculate the product of two matrices. Okay, two matrices. So that is the way of calculating the matrix product. Okay. So now the information in both the cases can be combined and expressed in terms of matrices as follows. So here like 2, 5, 8, 10 is multiplied by 5 and 50 for once, and then it is multiplied with 4 and 40 another time. So we can represent it in a single product way, and 5 and 50 is like they are written in single column, and 4 and 40 are written in second column. And then you multiply the horizontal to vertical arrangement and separately add them, and you will get the 4 elements in the final result. Okay, like if you multiply here, if you multiply these two elements to these and add them, you will get the first result. Then you multiply this to this and add them, so you will get this result. Then another time you will multiply this arrangement to this arrangement, and you will get the addition of this like this, and this is the result of third element. And then you multiply this by this in the last last row and last column. So you will get this. So that is how you will get the four elements in the final resultant matrix also. The above is an example of matrix multiplication. Okay. We observe that for multiplication of two matrices A and B, the number of columns in A should be equal to the number of rows in B. So that is very obvious thing. If you can like clearly see here, so the number of columns in A, that is, just see here. If you have like number of columns in A here, two are the columns. Okay. So this should be equal to the number of rows in B. This should be equal to what? Number of rows in B. That is 1, 2. So this 1, 2 should be equal to 1, 2. Here also you can observe that it has two columns, 1, 2. Rows 1, 2. So you just have to observe here that the corresponding column of first matrix, it should be equal to corresponding row of the second matrix. Okay. Their numbers should be equal. Furthermore, for getting the elements of the product matrix, we take rows of A and columns of B, multiply them element wise, and take the sum. Formally, we define multiplication of matrices as follows. So here is the definition of matrix multiplication. The product of two matrices A and B is defined if the number of columns of A is equal to the number of rows of B. Okay, that is, we have already talked in the previous discussion that column of A should be equal to the rows of B. Let Aij be an M cross N matrix. Okay, and B is equal to Bij be an N cross P matrix. Then the product of matrices A and B is the matrix C of order M cross B. So this is also very natural thing that if you have any matrix of order M cross N and the another matrix of order N cross B, then you will get the resultant matrix of order, like product of these matrices, you will get the order of what? M cross P. It means that the column of first row of first matrix, the like order of first, the number of rows of first matrix will be multiplied to the number of columns of the second matrix. That will give you the order. Okay. To get the kth element Cik of the matrix C, we take the ith rows of A and kth column of B. So this is also, we have talked that how to write the general formula of a matrix element. That is how they can be written like each separately. Multiply them element wise and take the sum of all these products. So like we have done earlier, that how the products of matrices are calculated. In other words, if A is equal to Aij M cross N, B is equal to Bjk N cross P, then the ith row of A is AI1, AI2, A dot 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 AIN, and the kth column of B is BIK, B1K, B2K dot 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 BNK. Then CIK will be AI1 plus AI1 into B1K plus AI2 into B2K. Okay, so this is like a representation of matrix multiplication by taking the your like column of first matrix equal to row of the second matrix. Okay, and how the like multiplication of these are done, and you will get the resultant matrix of order like if M cross P. Okay, so that is the general representation of that. The matrix K M cross P is the product of A and B. Okay, so this is the product of A and B. For example, if C is equal to this and D is equal to this, these are two matrices given, then the product CD is defined. Okay, so CD will be what? It is given by 1 minus 1, 2, 0, 3, 4 multiplied by 2, 7 minus 1, 1, 5 and minus 4. We just multiplied this. This is a 2 cross 2 matrix in which each entry is the sum of the products across some row of C with the corresponding entries down some column of D. These four competitions are So here the computations are done, and you can calculate each element by just taking the first row and second first row of first matrix and first column of second matrix, and then multiply the each corresponding elements and add them. Similarly, you do for second uh, first row and second column element. Okay, so by following this method, you can get the each element of your matrix production. Okay, matrix multiplication elements are like calculated like this only. So CD value is coming out to be 13 minus 2, 17 minus 13. Okay. Find AB if A is written like C9, 6923 and B is 260798. Okay. So you can also observe here that the number of column is equal to row of second matrix. Okay. Number of column of first matrix here. 1, 2 is the number of columns here, and 1 and 2 is the number of rows of second matrix. So these are here equal. You can observe this thing. So just multiply both the corresponding rows and columns of first and second matrix. You will get the result. Just I have like told you before, you can get the result. Like here, what you will do? 6 will be multiplied to 2 plus 9 will be multiplied to 7. Here, 6 into 2 plus 9 into 7. Similarly, for second column element here, you will get 6 into 6 plus 9 into 9. Okay. And then you will get 6 into 0 plus 9 into 8. 6 into 0, 9 into 8. Similarly, for this, 2 into 3, 2 into 2 plus 3 into 7. Here, 2 into 2 plus 3 into 7. And for the second, you will get 2 into 6 plus 3 into 9. 2 into 0 plus 3 into 8. Okay. Just compute them and you will get the result after product, like doing product. You will get 75, 117, 72, 25, 39, and 24 as the final multiplication matrix. Okay. So I hope that you got whatever I told today, and like I clearly told you how the matrices are multiplied. So we will now see what is the next thing to cover now, and then we will move forward and see that whatever we can cover today, we should do that. Okay. So I will rub the like drawings here. Here is a remark that if AB is defined, then BA need not be defined. So if the matrix is not a square matrix, then it is obvious that if AB is defined, then BA is not defined there. Why? Why? Because the first matrix has the same here. If you have 1, 1, 2, 2, 3, this has 2 columns here. Okay, 1, 2. But if you have second matrix as 1, 2, 3, 4, 5, 6. Okay, here you can see that you have how many rows here? Rows are 1 and 2 only. So here you can multiply them because number of columns and number of rows are equal. But if you multiply, this is A and this is B. Okay, so AB is possible here, possible. But can A be possible here? Here, B has 3 columns, 3 columns. It has 3 columns here, 1, 2, 3. But A has 2 rows, 1, 2. So is the number of rows of A is equal to number of columns of B? No. That is why your being A is not defined here. Okay. I hope you got this. But if the matrices are not square matrices, so this is not need. It is not need not be like possible that they are defined. like AB defined, so BA is also defined. So it is not possible here. Okay, let's move further and see the next thing here. If AB are respectively M cross N, K cross L matrices, then both AB and BA are defined if and only if N is equal to K and L is equal to M. So that I have already told you that if the matrix is two matrices are square matrix, then the only AB and BA are defined. Okay, because their rows and columns will be equal. Then both AB and B are defined same if and only if N is equal to N and N is equal to K and L is equal to M. In particular, if both A and B are square matrices of the same order, then both AB and BA are defined. Okay. Non-commutativity, commutativity of multiplication of matrices. So we will see that whether the multiplication of matrices is commutative or not. So it is already written here that they are non-commutative. Why? But AB is not followed that BA is also equal to AB. It means that AB is not equal to BA. Okay. If you can see if A is 1 minus 2 3 minus 4 2 and 5 and B is equal to 2 4 2 and 3 5 1, then find AB and BA. Show that AB is not equal to BA. So if you do your AB calculation and BA calculation, you will like get to know that AB is not equal to BA here. See here, AB is coming out to equal to 0 minus 4 10 3 and BA is coming out as minus 10 minus 16 minus 2 2. So there you can see your order is also not equal here, AB and BA. So clearly AB is not equal to BA here. Okay. So that is how you can prove the non-commutativity of multiplication of matrices. So till now we have seen many examples today, and also we have seen matrix multiplication, which is a very important topic for your boards and competition level exams. So I hope that you liked the today's session. If you have any kind of doubt or any kind of suggestion, you can just uh, message or comment in the chat box. And if you also want any private session or one-to-one session, you can tell us or comment in the chat box. So I hope that you like engaged with the today's lecture, and we will see the next part in the next lecture, and we will start discussion from the end, like where we have ended this. So thank you for the lecture. Have a great day.